Hi guys, my name is Chris and welcome to the first video of my series Z80 with Bread, in which I'm trying to build a Z80 based computer on a breadboard. Today I would like to look at Z80 CTC, which is this, because we're going to need it for the SCIO, which I will be connecting in the next video. And also I would like to finally connect the RAM so we can use the stack and more instructions. So let's get started. So let's start with connecting the RAM first, and then we can connect the CTC. I've already plugged the RAM chip in, and I have printed the RAM's datasheet, and I'm going to connect the RAM to the computer. So the first pins that I'm going to connect are the power pins, and the first power pin that I'm going to connect is the ground. I will get a jumper wire, and the RAM ground should be, if I zoom in, the pin 14, which is this pin on the bottom left. So I'm going to connect it. So this is the ground. Man, these jumpers are really bad, but they should work. Look, it's in. Now I'm going to connect the VCC, and VCC should be, according to the datasheet, should be right here on the top right. So this should be the VCC. It's in, and now I'm going to connect the address lines. So I'm going to get the datasheet for the CPU so we can see where the address lines are and we can connect it. So I have found the datasheet and I have it right here, and the address 0 is on the pin 30. So I'm going to get a jumper wire, this one for example, and the ground should be right here, if you can see it. No, move it. This jumper is the ground, and this should be the address 0, and the address 0 on the RAM should be on pin 10, which is the 5th from the bottom. So this is the ground, this is data 2, data 1, data 0, and this is address 0. Now I'm going to get another jumper, and the A1 on the CPU is right next to the A0, should be right here, and A0 on the RAM should be next to it. Go in. Now for the A3, I'm going to get a jumper wire, shorter one. This A3 is right next to the, sorry, A2 is right next to the A1. A2 is right here. Now for the A3, need some jumper wires here. A3 is next to the A2, A3, now A4, A5, A6, A7, A8, but this time on the CPU it is the same, so it is right here, but the A8 on the RAM is same as the EEPROM and it is on the other side, so it is fourth from the top. So this is VCC, this is write enable, this is chip select 2, and this is A8. Yes, this one it is. Now for the A9. A9 is same on the CPU as before, and A9 is right under A8 on the RAM. A10. Is here on the CPU, and A10 is this is A11. Next to it is output enable, and next to it is A10. Now for the A11. A11 on the CPU is on this side, so this would be A11, and I'm going to get a longer wire. So for example this one, A11, and A11 is right here. In the middle it is the output enable. And now for the A12, get a wire, this one, A12 on the CPU, and A12 I can get a shorter wire, so A12, and it is the last address line on the RAM, so on this side. The top left is not connected, and now we can add the data lines. So D0 is, I can show you the data sheet. D0 is pin 14. This is the interrupt lines. So we look at the CPU. If you can see under those wires, here we have the two interrupts, and above this is D1 and this is D0. So this one is D0. Here it goes here on the RAM. Now for the D1, maybe I can get a shorter wire, maybe. D1 on the CPU, I'll get under those wires, so I don't need to stretch the wire too much. So D1. D2 is on the CPU right next to the 5 volts, so this. And under the wires, D2. Now for the D3. D3 is this wire is the clock. Under that clock is the D4, and this is D3. So D3, and on the RAM it is from the bottom right. So this. Now for the other one, D4, and D4 is right next to the clock. So this, and above here, go in. Yes, I will zoom out so you can see a little bit better. Now for the D5. D5 on the CPU is under D3, so it should be right here. D5. Now for the D6. I can maybe get some shorter wires if I have any. This one looks a bit long, but it shouldn't matter. So D6 is next to the 5 volt, so it is right here. D6, and lastly D7. These ones are the same, but can use them. So D7 is right next to the D2 on the CPU, and D7 here on the RAM. Yes, it is in. The RAM is connected. Now for the control signals for the RAM. So we need to connect the chip select lines on the RAM, and the RAM has 2 chip select lines. One is, if you can see it, this one is chip select 2 and it is active high, and this one is chip select 1 which is active low. So I think that I'm going to just connect only one to my address decoder, and the other one I will just hardwire. And I think that I'm going to wire the chip select 2 to plus 5 volts. So the chip select 2 is the third pin on the RAM. I'm going to zoom in. And this is the 5 volts, and this is the go in. Go in. Yes, it is in. Now the chip select 2 has been hardwired, and I'm going to connect the chip select 1 to the address decoder. And on the address decoder, which is this CPLD, I'm going to connect the missing wire here in the middle. This is the EEPROM, this is the PIO, and in the middle is the RAM. And the chip select is under A10 on the RAM, which is right here. Go in, yes. Now I need to connect the write enable and output enable. And I think that I can just connect the write enable to the write line on the CPU, because the CPU has a dedicated write line which is active low, and on the EEPROM it is also active low. So I'm going to get a jumper wire, for example this, and if it is long enough, goes here, and it is the second pin on the bottom of the CPU. This is the, which is the CPU? This is the read, and next to it is the write, and it should be connected. Now for the output enable, I think I can just wire it low because it is active low and it should work, I think. So it is, yes, I need a longer wire, and it is the last pin that is missing on the RAM. It should be this pin. It's in, and now it should work. So now I'm going to connect the CTC, which I have right here. This CTC is just a timer for the Z80 computer, and I'm going to be using it in conjunction with this CIO, which is a serial input output, and I will be connecting this chip in the next video. So I'm going to connect the CTC. I zoom out. I will connect the CTC, for example, here on the bottom, and I will get the datasheet for it. So I have the datasheet right here, and if we take a look at the pinout, we can see all these pins. But first I'm going to connect the +5 and the ground, which is right here next on the other side of the 5V. So I will get a jumper wire. Here's the CTC, and the +5 is pin 24. This is pin 28, 27, 25, 26, sorry, 25 and 24. This is the +5. Now for the ground, which is on the opposite side, should be right here. It's in. The ground is pin 5. Pin 1, 2, 3, 4, 5. Now I'm going to connect the data lines. Yes. And I'm going to connect them to the PIO. I have the PIO datasheet right here, and if you take a look at pinout, if you can see it, D0 is on these two pins. This is D0 and this is D1. So D0 is this pin, pin 90. So I'm going to connect the D0 to the D0 on the CTC, which is right above the 5V. So this one. Now for the D1. D1 is right above D0, so here. Now for the D2, which is right on the left top, on the top left on the PIO. So D2, D2. Now for the D3, D3 is on the right side, on the top right side of the PIO. Now for the D4. D4 is under D3 on the PIO. So right next, and D4 is here on the top of the CTC. Now for the D5. D5 is under D4 on the PIO. D5. Now for the D6. And D6 is right above the chip enable on the PIO. So D6. And lastly, D7. And D7 is in the middle of D2 and D6 on the PIO. So D7, sorry, and D7. Now I'm going to connect the read signal from the PIO, and it is, when I look at the CTC, I think I'm going to connect the M1 first, because it will be easier to find the other pins. So M1 on the PIO. It is hard with these wires to find the M1. And the M1 is on the bottom of the CTC. Now for the other signal, which is the read. And the read is pin 35 on the PIO. So it should be this on the PIO, and the read is this pin on the CTC. Now I'm going to connect a clock to the CTC, and I need to connect the chip select on the CTC to some pins, and those chip selects on the CTC are used for selecting the channel on the CTC. So I think that I'm going to just wire them to the address lines, and I will connect the chip select on the CTC similar to the B/A or the control/data on the PIO. So I will connect them to the chip select 0, I will connect to A0, and chip select 1 I will connect to A2. And this is clock, chip enable, reset, and this is chip select 0, and the A0 I'll just connect it to the PIO, and I'm going to connect the chip select 0 to A2, and I have connected it to the control/data, which is this is the chip enable and this is the control data, and right next to it is the B/A for the ports, and on it is the A2, and I'm going to use it for the chip select 1 on the CTC. It should be right here. They both should be connected, and now I will connect the IO request because I have forgotten it earlier. And the IO request, it should be, no, it's not long enough. And the IO request is on pin 10, and this is pin 6, pin 7, pin 7, pin 8, pin 9, and pin 10. Yes. And the I/O request, I will just connect it to the PIO because I don't have long wires for the connection to the CPU. And on the PIO is right in the middle of read and M1. And it looks like that I don't have space, but the wire looks long enough to connect it to the CPU. And on the CPU it is on the bottom left. So if I just squeeze it through, yes, it is in. Now the I/O request is connected. Now I'm going to connect the reset and clock. And the clock needs to be connected to the system clock. So I'm going to use a wire. Here I have the clock, so I'll just plug it in, and the clock is on the bottom right. So get the wire through here, and the clock should be connected. The reset needs to be, it doesn't say, but it is active low, disables all interrupts, and I think that I'm just going to wire a similar circuit that I did on the CPU. So I'm going to take a capacitor. The reset is right here. Plug it in. And now I'm going to take a resistor. This should be the one. And I will pull up the line to 5 volts. And now it looks like that only the chip enable needs to be connected, and I will just modify my CPLD to add the CTC support. So I'm going to switch to my computer and we will modify the couple code. So here we are in WinCouple, and this is the code that we wrote last time. And I'm just going to add a new pin. This should be the CTC, and I will just not this, and on the CTC it is chip enable, so I'm going to write it correctly this time. So CTC chip enable. This can be the same, but here I will add pin 20 as the CTC chip enable. And for the CTC, I have modified my memory map so that the CTC is on addresses from hex 18 through hex 1F, and the couple code will look like this. So CTC chip enable will be low when IO request is low and A7 is low and A6 is low and A5 is low and A7, 6, 5 and A4 is high and A3 is low. This should make sure that the CTC is enabled only when it is in the range of hex 18 through hex 1F. Now I will save it, close this window and compile it. The design compiled successfully, and now I'm going to flash it to the CPLD. So the CPLD should be programmed, so I'm going to plug it in the breadboard. It wants to go in. Yes, it is in. And now I'm going to get a wire, and this should now be the CTC. I'm going to connect it to the chip enable, and it looks like everything has been connected. So now we can write some code and test the CTC out. So here we are in VS Code, and this is the code which we wrote last time, and I'm going to modify it so that we can use the CTC. So I'm going to write the addresses for the CTC. So CTC channel 0 is at address hex 18. CTC channel 1 is at address hex 19. CTC channel 2 is at address hex 0f. It should be, I'll get a calculator, and if I toggle the bits, sorry, these two should be high. Now it is 18, and this is the start. This is CTC. This is channel 1, and I'm going to, for the channel 2, I want the last two, the second from the end, so it will be 1E and 1F is the end. So 1E and CTC channel 3 will be equal to hex 1F. Now the addresses should be defined, and I will look at the programming on the CTC datasheet, and I'm going to configure. I will use channel 1, so under the PIO output I will create another label, and I will call it CTC init, and in that I will write load to A. I will write the value of 0B, and the most significant bit is for the interrupts. I will write 0 because I don't want interrupts for now. The next bit is the mode, and I will select the counter mode. Now for the prescaler, I will use the value of 256, so I will write 1. Now for the clock and trigger edge selection, I will trigger on falling edge. Now for the timer trigger, I will put a 0 here because I want automatic. Now for the time constant, I will provide the timer constant, so I will put a 1 here. the reset should be continued operation, so 0, and the control or vector, and I'm going to put a 1 here because this is a control word. Now I will load the channel 1 to the C register, so CTC channel 1, and I will output it to the CTC A. And the command will be initialize channel. Now I will provide the time constant, and the time constant that I'm going to provide is loaded to A, and I will provide 256 because it is the maximum. Now for the port, channel CTC channel 1, and I will output it, and this is the time constant, and this 256 will be multiplied by the prescaler that we have selected here, and it should be the 256. This is the third bit, so yes, it is 256, so it will be 256 multiplied with 256, which is 256 multiplied by 256, which is 65,536, and it will count to this number, and it should reset back to 0 and start counting all over again, and it should be everything. So I'm going to compile it. Main.asm integer range I will put FF, maybe, yes, worked. And now I will flash it to the EEPROM, and we'll see if the channel 1 will blink an LED. Now the EEPROM has been programmed and I plugged it back in. So I will get my LEDs. I will wire ground to ground. Should be here. And the timer out is on pin 7 and it should be right here, right next to the read. So, but I think I will wire some LEDs to the PIO so that I can see if it executed the PIO code and the CTC. So this last LED will be connected to the CTC. This last LED, and these LEDs will be connected to the PIO. So the 0 address ready, address table, age table, this should be A0. Now the A1, and lastly A2. It should be connected. Now I will power on my power supply and I will plug it in. Moment of truth. I will dim the light. Oh, it is shorting. Now, this is the A1 on the PIO, so the PIO looks like it is working, but the timer doesn't look like anything is going on. Maybe I can try another pin, so this one, and nothing. So I finally figured out what was wrong with my circuit. It was due to a faulty CPLD code, and the bug was in my logic. If you can see, I've mapped the CTC from hex 18 to hex 1F, and if you take a look at the binary, the A5, which is this one here, the A5 is high, and also the A4 is high on both sides. But in my couple code, I check the A5 if it is high, but then I check if A4 is slow, and that is the bug. So the whole time I was trying to program the CTC, it was wrong because the CTC was mapped to the SEIO, and that is from hex 10 to hex 17 because the A4 is low. And that was the whole bug. But I fixed it, and in my code, on my EEPROM, I've just changed the time constant from 255 to only 2, and I also switched to the timer mode because when I read the datasheet more closely, the counter works by triggering on the trigger. So the counter decrements every time the trigger is hit. And I didn't want that. I wanted the timer. So timer it is now. And if I dim my lamp and switch the circuit on, you can see the PIO still works, and now the LED from the timer works. And this LED is blinking. The LED should be blinking once every 8 microseconds. So that is why it is pretty dim. So that is pretty much it for today's video. And in my previous videos, I forgot to mention that all the code, the couple, the PIC, and the Z80 code will be available on my GitHub page. So if you don't want to write the code, you only want to, or you want to look at the code, it will be on my GitHub, which is linked in the description. So thank you for watching, and I'll see you in the next video. So bye.